discuss as we proceed, okay? Then we can save some time. So click this link right here for the first part. We're going to analyze the Archimedes principle. So then you will get a small software, a small simulation on your web browser. That should be look like this initially. Good, everybody have it? If you click the link, it should automatically bring it to here, okay? Okay, so to start the simulation, you can just click the begin, then it will look like. Good, any question? Everybody have it? Okay, now you can identify a couple of things. What is needed in here? You can see red color, some information on your left hand side, blue color, some information right hand side. So the right hand side on blue color, you can see it says fluid type. So by clicking on that, you can see you can change the fluid type. So we're going to test the buoyant force by using each of these fluid type: fresh water, mercury, gasoline, maple syrup, and then crude oil. Okay. So as we go on, so you have to keep track on what type of fluid we are using, and then how to get the information accordingly. And then below that you can see the bottle volume. By clicking this arrow, you can change that bottle volume. So the first one, we can start with the highest volume. So the highest volume we can go is 600. Okay, so keep it highest volume at first, and as it needed, we may have to change the volume. And volume given in milliliters, remember that's not SI unit, so you have to convert that. I will write it down, the conversion. Conversion is multiplying by each milliliter is each 1 cubic centimeter. Okay, remember that. And then your left hand side, you can see location. Location is important because we are doing this gravity, right? So you can change this with different gravity. So if you click the location name, you can see the name is changing. As a result, actually what it does, the gravity is changing. So, but we are not interested other gravitational effect. We interested only Earth gravity. So just keep it on Earth. And then bottle mass, you can increase. You can see the upper limit is 2000. The lower limit is, I think you can go to 100. So we can keep it upper limit 2000. So that's easy for everyone. If you're using the different numbers, that's totally fine, but make sure you write it down that on the data table properly. Okay, then let's take a look how we gonna do this simulation to understand the Archimedes principle. Okay, part 1 of the lab. So let's start from here, data collection. So the part 1, what we're gonna do, part A. So we're going to check the Archimedes principle. By using the Archimedes principle, we can do many things. One thing is we're going to check the buoyant force. Idea of buoyant force, now you know. If you have an object, and then let's say object is attached to a spring balance, and I slowly lower this object. Initially object is outside, let's say mass M, and then later we're going to lower this object and then fully submerge inside the water or any fluid. Okay, this can be any different fluid, let's say rho. And as you submerge here, you will see the spring balance show you the number that is actually the real mass when it is on air. If it is on water or any fluid, this number will change into different number, m prime. M prime is always less than m, right? Because why? So that's what the Archimedes explained. If you take a look at the free body diagram here, we have real weight downward direction, tension force upward. But when you take a look this one, tension force is actually not represented in the real weight, right? That's the problem. So that's where Archimedes explained this behavior, right? This is actually m prime g. M prime g is not equal to mg. So the explanation he found, when you submerge the object, there is a certain amount of fluid will disperse from the due to this submerge. Because of that, he figured out there is another force acting upward direction, what we call the buoyant force, FB or U, depending on how you want to write. You can use any of the variable, but make sure you write it down those in your report properly. Okay. FB, he figured out that weight of the displaced mass, or the displaced mass of the water, which is equal to the volume of the object times rho of the fluid or liquid, use FL here to represent the liquid, times the gravity. So if the object is fully submerged, then I can use sum of all forces equal mass times acceleration on y-axis plus u, which is equal mg. I can use this one to understand, for example, the buoyant force. Now the buoyant force equal mg minus m prime g. So which is m minus m prime times the g. So I can calculate the buoyant force, that part of the lab. So we will test that concept. Okay. And also, if I know this information, then by using that information, I can find density of the liquid. How to find the density of the liquid? We know buoyant force, which is equal volume of the object times density of the fluid times the g, right? So which means density of the liquid is equal m minus m prime times the g divided by volume times the g cancels out. We're going to have new equation to find the density of the fluid. So that's the other part of the experiment. So the part A, we actually testing two things. One is the buoyant force, and then by using the buoyant force, we will calculate the fluid density, and then we'll compare this density to the standard values. For example, if I use water, then I know water should have to have a density. The fresh water density is not exactly 1000, it's slightly off. So the fresh water should have 1020, roughly about 1020 kilogram per meter cube. And then if I use oil, there should be a number. So you can see the mercury has to have a 13,600. Gasoline should have about 780. Maple syrup is 1370 roughly. And then all these are, we know the standard values. So we can compare number we're calculating by using this one. If everything is correct, then we should get really, really less percentage error, okay? But when it comes to gasoline and maple syrup, actually it's not one number, because there are different type of gasoline and then different type of maple syrup depending on how you made it, right? The concentration, everything slightly different. As a result, these numbers are average, right? So we might get some error there because I don't know which number exactly the simulation they are using. So that will be a problem. Otherwise, the water and mercury, we should get fairly good number, very less percentage error. That's the plan. Okay, any question? And how to extract these numbers? Now you know mass and directly we can measure, right? If I have a spring balance, if we do this in class, that's what we're going to do. We're going to hang this object, we're going to measure the mass directly. But in the simulation, we can't do that, right? Because in the simulation, we don't have that facility. Instead, what it does, you can see this is small black box right here. So that black box is actually a force sensor. So that will tell you. Sure. So this is small black box which is actually attached. So that is a balance, type of balance, but that is electronic force sensor attached to that. As a result, after you run the experiment, run the simulation, you actually will see automatically what is the real weight. Directly the force sensor will give you actually a graph like this one. So the force versus time. So what it does now, for example, let's run this one to see how it happened. Now this is outside, right? So what we're going to do when we start the simulation, you can see it's slowly going to immerse the object, as the object is submerging, you can see force is slowly decreasing, 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 and then it's starting to saturate, right? You will get a graph from the force sensor look like this. Right, this is outside. This is when the object is fully outside on air. This is when the object is fully inside on the fluid, right? So which means if I extract this number directly, so that number is about 19.5. You can see it's like slightly thicker lines, right? Because it's a lot of data points. It's not just a single line, it look like that. You have to measure to the middle point, okay? Midpoint of that thick line, then we can extract to 19.5 unit Newton. And then if you go in here, then you can extract the M prime G. M prime G is about, according to this is small, each of the small dot represent 1 Newton. You can see unit Newton on one y-axis. This is 10, 11, 10, 11, 12, 13. So I can extract this into 13.5. 13.5, that which means I already know M times G real weight, so that is the force when it is outside, 19.5 Newton. M prime G when the object is inside the fluid fully submerged, so that is 13.5. By using those information I can calculate U, buoyant force, and also I can calculate rho of L. So that's the idea. So it's very simple. And we're going to do this by changing the type of liquid, at least 4 different type of fluids, and then we'll compare those numbers to the existing or known numbers. So that's a plan. Very simple calculation. Okay, any question? Good, let's continue then. Okay, now what I want to tell earlier, so when you're doing this, it is easier if you actually build all this with your Excel, right? So if you go into the Excel sheet, do you see the Excel sheet which I sharing? So Excel sheet, you can actually build this data table. Right now, the data table 1 right here, you can copy paste this whole table into your Excel sheet. Then it's going to be look like this automatically. Then the background and then all this formatting you can do later, right? So the Excel has all those features. So for those you can do the data sheet 1. I just need only these columns. Just from here, the column number, column names. You can do the formatting later, okay? Don't worry about formatting too much. You need to format nicely before you do the lab report, but that you can take time. And then also make sure you add the table name, table 1. When you name in the table, just don't say it is table 1. You have to name it, right? In your report, table number 1, what you do. You analyze in the Archimedes principle, or you can say analysis of Archimedes principle, some name, okay? You have to name the table, analysis of Archimedes principle, okay? Good, any question? And then I need one more column because I need few more rows, right? So those you can actually format as you go on. So I need at least 4 different rows. You can adjust the size and everything. Those things can be done later. So let's continue. The first fluid is water. These names, if you download this PDF file, you can copy paste that. Otherwise, you don't need to copy paste. You can just name it yourself. Okay. You have to make the table anyway. Okay. Yeah, just write it down. These names. You can see the names there. Just write it down it here. Okay, so the first one is water. So I need the force when the object is on air. And remember a couple of other things. You need the units. So I will leave another space here to apply the units properly. So every column must show the units. So the unit Newton. Second one, force unit Newton. Third column, apparent weight of the object. That is also unit Newton. That is buoyant force, apparent weight. Apparent weight of the object and the buoyant force, that is also Newton, and the density. If you can't copy it, just type the names. That's it. Okay, guys. So you guys are in first year or second year in college level, right? This is not a high school class. So there's nobody to babysit. Okay, so you have to figure out certain things. Only information will be provided. Okay, I'm not going to give you the whole table and then ask you to fill it up. That's like you are in the fifth grade. Please be mindful and then be wise. That's something you have to gain yourself. Okay, mindfulness and the wiseness as you proceed. Otherwise, you are not showing the maturity what is needed at this level. Okay. All right, so the density units is kilogram per meter cube. So I'm showing you this formatting that you have to do it yourself. Okay, formatting I will not gonna do it for you, and also the tables I will not give you the Excel sheets. Then you have nothing to do. You just put the numbers there, and then it's look like a fifth grade or second grade work. Okay, guys, so the formatting you have to get practice, okay? If you're not familiar with the Excel, that will take time, first few labs. People who did Physics 1 class with me should have to have a really good experience now with the Excel because we use Excel for 10 or 11 labs there. Other people who never use the Excel, that's totally fine. You have a chance to learn it now, okay? It's a learning process. Don't worry about too much. You can learn that. Okay, good. Any other question? This formatting you can do even after you copy paste this whole table into your Word. There also you can do the certain formatting. Okay, you can rename, adjust the name, size of the fonts, things like that. You can actually change there too. Those are not very difficult. You will learn very quickly. Okay, question. All right, then let's continue. May not be. We may have to change that really, okay, depending on the situation. Please make sure for each case include the mass of the object and the volume because that is we needed as we go on. We need that for certain calculation. Okay. So the mass of the object right now is actually 1,000. So I'm gonna write m is equal 1,000 kilograms. Make sure the units 1,000 grams, right? Please follow the units. It is 2000 grams, 600 milliliters. Let's write that here. 2000 grams means you can write in SI units. That is good, I think. 2.000 times kilogram. And then volume V, which is 600 milliliters. Remember, that is not the right unit, okay? You have to convert that unit. Now, the conversion, I will write it down here, the unit conversion. Each milliliter is 10 times is actually 1 cubic centimeter. So each 1 milliliter is equal 1 cubic centimeters, right? If you convert, which means if I convert milliliters in cubic meters, this is the conversion. You know, you have to write it down your numbers. You have to measure yourself, okay? So the each centimeter is 10 to the negative 2. Because of that, you will get here 10 to the power minus 6. Each 1 milliliter is actually 10 to the power minus 6 cubic meters. Okay, good, that's a conversion. Okay, then write it down, the numbers we extracted. So the force when the object is here, I read it to the 19.5 because you can see, if you zoom in this small graph right here, you can see each of the small small square represent about 1 Newton, right? So always when you're reading manually, you can actually add another extra decimal place, right? So which means I can read in between these two lines, small lines, so I can add the 1 decimal place to each reading, right? So that's why I read this into 19.5. That's important, okay? And then when the object is fully submerged, I'm reading this to 13.5. So you have to read that also carefully. So this is the line. You can see it's not a single line. It is a very thick. It's actually data points, right? So you can see it is actually in between 13 and 14. So I can 10, 11, 12, 13, 13 and 14. So I'm going to read into 13.5. So we can add 1 extra decimal place accordingly. Good. So the apparent weight of the object, you know, apparent weight is actually what's the object is, when the number or the real mass is not showing up when the object is fully submerged. So that is actually what we call apparent weight, right? So you can find the apparent weight, nothing to find really, that number is right here. And then the buoyant force. Buoyant force we have to calculate, right? Apparent weight is same as the object is fully submerged. Buoyant force is actually different between real weight and the apparent weight, right? So when you do the Excel, you can actually do the calculation as you go on. If you want to do any calculation, put a equal sign. Now I have to get the difference between these two, cell minus, click on the other cell, hit enter button, it will do the calculation automatically. But remember, since I'm reading for 3 significant figures, I can actually do all these calculations for 3 significant figures. So you have to format these cells. So if you highlight, right click, format cells, put it into at least 2 more decimal places, then it will show you into 3 significant figures. Okay. This is important to 3, but these I need only for 2. So I have to reset or reformat every cell accordingly, okay? So this I need only for 1 decimal place. Okay. So now you have 3 significant figures on this row. And to calculate the density, what you need? So to calculate the density, you need the difference between masses and then divide by volume, right? So if you take in the difference between the weight, then you have to divide by volume times the gravity. Okay, remember that. So you can do this way also. Rho of L, which is equal force of gravity, that is mg when it is outside, m prime g, divide by v times the g. That also correct. Since we have all of these numbers directly, then we can use this. But when you're dividing, you have to divide by gravity, right? So let's do that. Right here, I need equal sign. Equal sign. So the buoyant force, technically the difference between these two, I already have that. Divide by parentheses. That's why you need actually this volume parameter here, right? Correctly. So you have 600 milliliters, right? Which means 600 times each milliliter is 10 to the negative 6. So you have to do it accordingly, 10 to the negative 6. 600 times 10 to the minus 6 times 9.81. Okay. 1019.37. So now later actually correction will asking you to do a percentage different. You can see here density of the fluid, and then later on the table number 2 question asking you to do the percentage error values. Please change this freshwater standard value should be 1020. That's this very accurate number should be 1020. Now this is very close to that. Good. Any questions so far? So volume is 600 milliliters. Okay. Okay, then let's continue to the next one. You have to do that calculation, right? You can see here, this is the formula. You have to build the formula yourself on Excel. Okay. You have to build that formula yourself on Excel. I will write it down, that Excel equation which I using. So this is a calculated value. This is the equation which I use. Let me copy that just below that calculation. Then you can see how actually that calculation is done, right? That's how that calculation is done. Equal sign must go in front, okay? When you do any calculation with the Excel, equal sign should be there. That actually tells the Excel to do the calculation. That's the idea, okay? So that's the equation which I use. Good. Okay, then let's continue. Okay, so that's now you can see as we go on to the next and then so on. So this calculation actually much easier, because if you do for one cell, then the rest you can do very easily. So let's continue. So all we have to do now is actually change the fluid type. So you know, if you click once, fluid type will change. You have to reset before you do any changes. Okay, don't change the mass or the bottle volume yet. Change it to mercury, and then that's fine. If you read the different number than mine, use your number. That's totally okay. Yeah, if you use a different number, but if your volume is also different, you should get about the same number. That's totally fine. Okay, reset it, change the fluid type into mercury, and then start button, check whether object is fully submerging, okay? You can see mercury is very dense now. You can see object is not fully submerged, so I can't really get the number for the apparent weight, right? Because of that, what you have to do now, which means the volume is too high. As the volume is too high, buoyant force is actually too large. So I have to change that, which means click this blue arrow downward, make the volume really small, the smallest possible number we can get. The smallest possible number we can get, which means 100 milliliters. So now, which means on the second case, mercury, we are doing mass, we're going to keep the same number, 2000 kilogram. I can say 2.000 kilogram, that's okay. And the volume we are using only 100 milliliters, okay? 100 milliliters. And let's collect the numbers then. So now you can start this again. We need it to fully submerge, okay? That's the idea. Okay, now you can see the bottle can fully submerge, okay? So that's all then, just collect the data from here. Real mass should be the same, right? Real mass will not be different. Excel sheet is right here. Do you see my Excel sheet? I'm sharing both of them. Excel sheet. Excel sheet is there. All the calculation, all the equation you can see there. Okay. These are the observed values directly. Apparent weight is same as the Apparent weight is same as the force when the object is fully submerged. This is formatting, okay? This formatting you have to learn. So look like you need to check only numbers, okay? If you get in this final answer close to 1020, you find. Anything else is formatting. Formatting, you have to learn yourself how to format the Excel. You have to spend time on that, okay? This I can't do Excel class actually, so that we don't have time to do that. That will be a problem then, okay? Make sense? All right, guys, please continue. This is your data sheet. This is the data sheet you're doing right here on Excel. There's no other data sheet. You don't need to do anything else. You create this for this all the calculation here. You copy paste that into your Word. Okay, so that's where sometimes you are spending unnecessarily long amount of time because you create this data sheet on the Word and then try to type again everything there and then do all the calculation by using the calculator. So you are spending a lot of unnecessary time. So that's what I'm telling you. You have to gain some skill how to do this data analysis by using a software. Calculator is good for exams and maybe up to the high school level. Beyond the high school, do not use the calculator for any of this kind of work. Not meaningful. Not going to give you any skill you need for today's world. Okay, so you have to think about where you're going after this. So you're going into a very technologically advanced society. Okay. So you have to gain the skill needed. All right, so we'll continue. So the mercury, the real weight should be the same, right? So should not change when it is here. But when you submerge fully, now you can see it's on the different location. Try to read it as accurate as possible. So these dots are in between 11 and 12th line, right? So I can read that into 11.5. Now you can see that changes as a result. This changes. Now, when you're doing this calculation, you don't need to redo again. You just copy what you done earlier here and then copy and paste into here. So it will do the calculation automatically. So the copy here and then paste into here. So you see it doing the calculation automatically. Okay, question. Yeah, because you have to change your volume. Volume should be 100 milliliters. If you're using the 600, you will not get that. So see that numbers are right here on your screen. Please follow that. Okay? Oh, this is actually 0.6. Sorry. Yeah. This is 5. This is 6.5 actually. Yep. Good point. So you have to correct that. 6.5. This is 6.5. Now this number you can see this is not correct because when I copy paste the previous calculation here, when I calculate the previous calculation earlier, volume I use 600, right? I have to change that. Which one is constant? Which one is constant? Correct, yeah. So you extract the numbers when the line becomes a horizontal line. That's right, yeah. So the very top and the very bottom, you read in the value. Now you can see this number is not the density of the mercury because that should be 13,000 something. The reason when I do the previous calculation here volume was 600. I have to correct that. Now if you click here and then just change this into volume, now I have 100. Now you can see the right number 13,251.78. So the density of the mercury should be, you can see the standard value here, 13,600. That's close enough. Okay, we have some error, but that's okay. If you do this in class, you will get really huge error. Mercury we can't even do in the class, but if you do even for water, we will usually get in like 10-15% error. Okay, then likewise you continue this. So you done for mercury, and then what next is reset the whole simulation. Gasoline, volume and mass. You can put back the volume again into a 600 maximum value, which means you can copy paste actually these numbers because those are same. So let's copy paste into here, and then I need 19.5 will be the same. That's a real weight, and all you need is let the simulation run. Wait until the line becomes horizontal after it fully submerged, and then extract the value from there. That's it. So it horizontal now, then the number should be between 15 and 16, right? So I can read that into maybe 15.5. So that's it. So this should be 15.5, and then the last two columns you don't need to redo. You can actually, you already have the calculation, you just copy paste that into here. Then it will automatically do the calculation for you. It will pick the right cell and then do the calculation automatically. So that's the advantage, okay? Now again, you can see this number is inaccurate because earlier volume is 100, but I need the 600 volume now. If you do any changes, you have to change that accordingly. I'm getting 679 if you go to the gasoline standard value, which is about like 780. That's okay. We have some error there because we don't know exact which gasoline density the simulation is using. So that's nowhere those information can be extracted. That's fine. So the last two, gasoline and maple syrup, you will get some high error. That's totally fine. So the maple syrup, you can keep the same information, mass and volume, but the term should be changed into maple syrup. Okay, and then real weight should be 19.5. I just need the apparent weight. To get the apparent weight, all you need to do, reset the simulator, change that into maple syrup, click start button, wait until the object is fully submerged. That's it. So after it fully submerged, you zoom in this graph little bit and then extract the number here. This is in between 11 and 12. I can read that into 11.5 now, right? 11.5. This is 11.5. The next two, I can do the calculation directly. There you go. So that's why if you use in the Excel, this calculation and everything is very, very easy. Okay. So that's why I'm telling this, try to practice this. If you still using the calculator, so you are in the high school or below 10th grade level, that's not suitable for you or your future, will not give you anything good. Instead, it dragging you towards the backward in time. Okay. Please try to think about what comes next, not what you done yesterday or 10 years ago. That's not important. Good. Any questions so far? Everybody okay now? If you're not familiar with the Excel, that's totally fine. I can fully understand that. Nothing to worry. Get to work. You can get practice. All right. Then you can format later. I'm not going to spend formatting. And then, for example, now you can see top row, you have a black line, but the bottom, I don't have it. If I want to have the black line, all the formattings are here. You can do the formatting later. You can see different type of formatting you can add. All those things you can do before you copy paste this into your Word file. And then since, for example, we'll say this is a single column, this whole thing single row. If I want to get this into a single row, you can highlight all of those and then merge that cell. Right click, then merge cells. Where's the merge cell? Somewhere should be here. Let's take a look. Those formatting, you can just play around with this. It's not really big deal. So you can find as you go on, okay? Merge and center. Yeah, you can do that. That's fine, I think. Those things you can learn. It's not big of a deal. Anything like, for example, if you want to learn something, how to format or anything, there's a good help actually included in here. All you have to do, write it down on this help. You can see help term right here. See, when right here. So you can see a search term, right? So if you want to find anything, for example, you want to find merge, just type merge. It will appear there. Just double click. It will tell you how to merge, or it will do that for you automatically. Okay, all the information actually already there. Okay, you just need to search around and then see how to get that information done. See? So it will tell you what to do, how to do all the information. And also there's millions of small YouTube videos you can even find how to do this. It's not really big deal at all. Okay, those things I will let you do as you learning this later. Okay, but at this point, now we done the first table. Let's go into the second table since we have only 1 hour left. Okay, good. Any questions so far? So then you have to table number 2. I will show you table number 2, only one part. When you upload in the data table for the end of the class, you know you have to upload this data table every day for the lab case. When you're doing that upload, you don't need to have the complete data table with all the calculation. Whatever you've done, I need to see that. That's all really, okay? You don't need to worry about completing everything, formatting, all the calculation. You don't need to worry. All the data collection must be submitted. Whatever you have on Excel sheet, just upload that. Now I will show you the data table number 2, only little bit here, but the rest you have to do. Okay, table number 2, let's do only first part. Table 2, let's say error analysis or uncertainty calculation. You can say percent error calculation, percent error analysis. That's our topic. Analysis, so I should have type of the fluid, right? Name of the fluid, and then you have to make exact table like on your lab manual. Let's take a look. What's the other columns? Calculated density, expected density, and percentage error. Okay, so calculated density. Calculated density, and then I need expected density. Expected density, then I need the percentage error, PE. Okay, I'm just going to put PE, but you have to write it down that. Okay, if you want to have more space here, you can expand that. Those things you can do as we go on. Name of the fluid we do in the fresh water. You can copy paste actually all the information from there directly if you want to. So we're working on water. And calculated density, don't write it down here. Instead, actually, you can copy paste directly this number, right? So you already have it here, calculated density. Just copy paste that. In here, when you copy paste any calculated value, you have to do this. Paste here, and then right click or click on this icon, paste, and then do the paste value as a values only. Otherwise, it will not show you as a right number, okay? And also, you can reformat everything. All these values you can reformat. This cell, let's reformat that in to show scientific notation. For example, scientific notation with maybe 2 decimal places. Then we have 3 significant figures. See that? So that actually very useful. If you do that for all of these, then you will get the right significant figures. Okay. All of this you can actually practice, but you have to spend time. Okay. So that's something which most of the students don't wanted to do, is spending time. So you have to spend a lot of time to learn this kind of things. Okay, now I need only 3 significant figure here to reformat all of this into scientific formatting, to the scientific formatting, and 3 significant figures. Good. Yeah, gasoline and maple syrup, you will get huge percentage error because we don't know what numbers the simulator actually using. That's okay. So the expected value for water is 1020. Okay. And the percentage error, how you do that, equal sign, absolute value, ABS, parentheses, calculated, sorry, not the calculated value, expected value minus the calculated value, divide by expected value, everything multiply by 100. Okay, that's the percentage error. You can see it is very small because it's written in 3 significant figures but 10 to the negative 2. Okay, everything should be properly organized this way. Let me copy this also for reference purposes. You can see how I did that calculation. Now that's why I'm telling you, do this way, then your time actually can minimize by large if you do this way instead of the calculator. Okay, don't try to use the calculator for anything during the labs. Really, you can do everything on Excel or any other advanced software is fine. Okay, let's continue to next part, table number 3. The rest of the calculation on table 2 you can do. Okay, anybody have any question so far? Anybody have any question? When you upload in the data sheet for in-class data sheet purposes, don't worry about completing all the calculation. Okay. So what I did, you can format any cell any way you like, right? If you want to format this part, highlight that, right click, format cells. I'm using scientific notation because I would like to have a certain number of significant figures. If you want to have a certain number of significant figures, any number, you have to do scientific notation. And in scientific notation, usually write one number and the 10 to the power value. You have to tell how many number of decimal places to get the right sig figure. So I need 2 decimal places because then I will get 3 significant figures for all the calculated values, right? So that's the idea. Then I have 3 sig figs for all the calculated values. Okay, now you can see, look at this number, it looked like 1.02, but actually inside it has all the calculated numbers. Okay, it is not really 1.02. When you do the percent error, you see automatically it considering all the numbers you already have. So that's the advantage, because if you're doing this on your Word file, you can't really do that. Okay. And also any other later adjustment you can do very easily. If something goes wrong, you can come back and then always readjust any of these information. Okay, guys, so let's continue to next part. So the next part, we're going to check the Pascal principle. To get the Pascal principle, you need the different type of simulation. Just click on here. That will open up this simulation. That will open up a new simulation. Click on begin. So that's our simulation for the Pascal principle. You know, Pascal principle is actually how the pressure change. Inside the U-tube, there should be a water or any other fluid, and then there should be a 2 pistons, and then pistons has to have some weight, right? So let's take a look what we're doing on Pascal principle here. This is part B. So I have a U-tube connected this way. So left hand side we'll taking as a large tube now. It doesn't matter, you can do this any way you like. Okay. Right hand side is actually smaller tube. So I have a larger tube here Initially that's a piston, and then you have a heavy weight on top of that, same level, and then you have the other piston, and then there's a weight on top of that. Now, if these weights are different, what will happen? You can see in the middle there's a black line is actually holding the motion, right? So right here there's a pin. So when you release the pin, you can see the cylinders are moving and then get the equilibrium. Then just below here, it will say system is now in equilibrium. Then only we can read the numbers, okay? Now, before you start this one, you have to set up the numbers properly. So you have to set up the tube number 1, 20 millimeter radius, tube number 2, 50 millimeter radius, and the larger one should be 50, smaller one should be 20. And then the larger one should have about 1300 gram values, okay? So let's adjust those numbers here. Larger one, change this into 50 centimeter radius, reduce this one into 20 centimeter radius, 20 centimeter radius, and then change the mass on this smaller tube into 50 grams. Mass on the larger one into about like maybe 1300 gram. Just click this up arrow, then you can change the numbers accordingly, okay? Exactly 1300 gram. Okay, now at that point, if you release this pin, then these cylinders will move and then balance at a new location. You have to decrease the mass inside the tube, smaller tube, all the way to 50 grams first, okay? Change the mass into 50 grams first. Good. And then after if you release the tube, then this will move into a new location. So the new location gonna be look like that. That's the new 2 location. So at new location, so then I can find the pressure inside here. Just say this is 0.1, and then let's say this is 0.2. Then I can find the pressure. Pressure at 0.1 should be equal pressure at 0.2. Pressure at 0.1 should be mass on cylinder number 1 times the gravity, total weight acting on there. You can add actually atmospheric pressure if you want to, which will cancel out both sides. Pressure on the other side, mass on the other side times the gravity, plus weight come from the water column, right? That is actually this height h. So h times rho of the liquid times the g. Okay, so what we're going to do, we're going to calculate now. P0 cancels out. This side is actually, I have pressure on, let's say, my left hand side must be equal to the total pressure on the right hand side, right? So what we're going to do, we're going to calculate these two pressure by measuring this height, and then we're going to check whether I have the same pressure on both sides or not. If I get the same numbers, then which means the Pascal principle correct. If not, Pascal principle is not correct, or maybe we're doing something wrong in the calculation. So that's how we're going to test this principle. Make sure all these numbers, okay? Your right hand side should have a radius of 20 millimeters, and then mass of 50 gram is starting point, and left hand side radius of 50 millimeters, mass of 1300 gram to start with. And also, whenever you want to make any changes, this pin should be properly here. When you take the pin out, click on the pin, you can see now the positions are at equilibrium location, okay? You have to bring the pin back and then adjust any adjustment, okay? Good, any questions so far? That's it, it's simple calculation really. Let's take a look how to do the calculation then. Anybody have any? You have to adjust that. You can see there's a large arrow and a small arrow, right? So the large arrow mean you changing large numbers. The small arrows mean you changing small numbers. If you want to change small numbers, click the small arrow. Then that will change like each 5. If you use large arrow, that is changing like each 10 or 20 or 30. You can't get the number you needed. Okay. These are just like you playing the video games or things like that, right? You just need to play around, right? Don't worry about too much. Okay, just play around. You can really find it out. You guys doing much more complicated stuff than this one on computers. Okay, so right. Even the small computer game is very complicated than these simulations. So it's not big deal. All right, guys, so let's continue now. Everything set up on our first data set we can extract. So let's take a look the part B. There's two tables again, Pascal principle. So the table number 1, mass, position on the mass of the tube 1, position of the piston 1, position of the piston 2. By knowing those two, I can get the separation, right? Let's continue that. Okay, you can set up that and then type those terms. I'm going to copy paste from my previous table. Okay, I already had the table here. So I need actually this information. So you don't have all this information already there, so you have to create the table, okay, accordingly. Since I have the table, I just copy paste that. Okay, so the mass of the tube 1, we're going to start from 50 grams, and 50 grams mean in kilograms about 0.5, okay, remember it's SI units. And then I have to read position of H1, position of H2, but I don't interested any of those. What we interested is actually separation between the piston, right? This H, right? This H is actually technically equal. This is H1. This part right here is H1. This part right here is H2, right? So the technically equal, this large H is equal H1 plus H2. Good. But when you're reading this in the simulator read actually, it has a scale right here, right? It has a scale there, but it's reading this value here, and then you have to read this value, the top value from here. So which means technically it reading this as H1, this as H2, which means this H is equal absolute value of H1 minus H2. Or H2 minus H1 doesn't matter, but we need just a number, okay? That's a small difference than which we done in the class, because in the class this is your 0 point. But on this scale, 0 point is somewhere here. This is y equals 0 point, okay? Because of that, remember, there's a small difference there. Otherwise, we will get some confusion later. Okay, so let's continue. Any question? Good. All right, let's read that. So this is very simple. Get rid of the pen. Wait until it equilibrium. So the middle, it should say system is now in equilibrium. Otherwise, the system is not ready to take the data. Okay. When it equilibrium, you can see now. You have to read this, right? You can see there's a scale on your right hand side and left hand side. Vertical scale. That scale is in millimeters. See this? It says distance is in millimeters. Okay. And also you can read like on previously in between lines. Each line is about like 10 millimeters, which means whatever the number you read in between gonna be about 5 millimeters value, okay? So this number H1 right here, which means 250, 60, 70, 80, and it's little bit above the 80, but I can't read that into 85, okay? I'm gonna leave it like that, 280 millimeters, but I need in meters, which means 0.280. I need at least 3 significant figures here to represent that correctly, the numbers which I read, right? So the position of the M2, which is at 400, 410. 0.410. Good. 3 sig figs, and then different, equal sign, absolute value, parentheses. You can take anyway this different if you use in the absolute value. Okay. So the 0.130. Let me copy paste that. Function which are using ABS. Remember, any function whenever you want to use with the Excel should have to apply with the equal sign. Okay. ABS, then the cell value minus the other cell value, that will automatically give you the positive answer. Okay. So these are the function which I use for H. This is function for H calculation. Okay, good. Any questions so far? Okay, then let's continue. I need to get this data for few other mass values on my right hand side. Let's reset this. Click this small pin in the middle, black T-shaped thingy. Click on that. And then increase the mass of the smaller tube side by 20. If you click one time the up arrow, right hand side bottom, larger up arrow only once, it will change 20 at once. If you click a small arrow, it's changing 5, right? You have to click it 4 times to get it into the right number. And after that, you get rid of this T and then let the object move and then wait until it say equilibrium, then extract the numbers. No, this is M2 because now what we're doing is your left hand side. So it's, when I draw here your left hand side, this is M1 and then this is M2, right? It doesn't matter as far as you know what you're doing, right? You can name this any way you like. It's a naming purposes, right? But you should know when you're doing the pressure calculation, which is your mass 1, which is your mass 2, and then so on. That's all really. So this whole thing should be added together here to get the pressure on right hand side. This is the pressure on left hand side. As far as you follow that, you can name any way you like. It doesn't matter. Okay. So how I name here now is everything on your right hand side is actually name it as number 2, left hand side naming as number 1. Okay. Good. Any question so far? Technically, 3 decimal places. Yeah, actually, yeah, because we're reading this into actually 3 significant figures. But if you take a look, this is smaller graph sheet right here. You can read in between, right? So which means technically I can read these numbers into 4 significant figures. So we will leave 4 significant figures in all of these calculations. No, you can use any masses you like, but one thing you have to keep remember, you have to read this sentence right here. It should show you system is now in equilibrium before you take any data. If you try to do with any mass, system might not show you this equilibrium condition. If it say not equilibrium, then the numbers will be inaccurate. Okay. You can use any numbers you like, doesn't matter. Any masses on both sides. You can play around with that. But one thing to keep that mind, later calculation will be inaccurate if you don't have this sentence here. Okay. All right. So that's it then. So put it into 70, make into equilibrium again. Read the H1. H1 is now 20, 250, 60, 70, 80. Now you can read that into 85, right? 0.285. And on the other side, I can read that now into 390 and between 400. I can read that into 0.395. So this calculation, when you do it once, you don't need to do it again. You can just click and drag. You click and drag, it will automatically do the calculation for you. You can see this the last tree now it shows 0 because there's no data here. As you populate these columns, this calculation automatically does the calculation for you. Okay, just leave it like that. And then reset. Click up arrow button once for M2 and then let it move. Wait until it equilibrium. Read the values H1, 250, 60, 70, 80, still close to 85, right? There's no much difference. That's where we're going to see some error in next calculation. 285 millimeters this side, which is very close to 380. So we have to read that to 380. There's no meaning reading any other numbers than in between value, right? You can't just say 382 or anything. That's not meaningful. I can read either 385 or 390, but we can't read like 382 or something. That's not much meaningful. Okay, let's read this into 380. 0.380. See, when I populate the numbers, the last column automatically do the calculation now. So those are the advantage than the calculator, right? That's the whole advantage. This is very simple thing, but if you have a large data set, now we all talking about this big data. If you want to do the big data analysis, you have to use very advanced software like Python or maybe MATLAB, something like that. So that's actually going into the machine learning. Then you tell the machine something to figure out, tell me this and that. That's simply called the machine learning. So this is part of the machine learning automatically. Machine does it for you. It's not big deal, right? It's starting from there, then it go into the very advanced level. Okay, then click the up arrow button once, 110, make it to move. Wait until it equilibrium. Make sure this sentence should show you equilibrium condition. Then read the numbers again. This side is close to 290, so I can leave it like that. 0.290. And then this side is now at 350, 60, 70, which means 0.370. Okay. And then let's continue. So that's why using the simulations are very, very easy, right? Than the in-class calculation. Next calculation, 130 grams. Click the black T-shape and then wait until it moves. And then zoom in and then observe this number. This is now exactly 290, very slightly above, but we can't read that into 295, right? Read it to 290 millimeters, and the other side 350, and now it is in between 50 and 60. I can read into 365.365. And when you do that calculation, you can see it does automatically the last column. Okay, see the advantage. So that's why the using Excel is much easier and an advantage compared to your calculator. Okay, now let's take a look how to do the table number 4. Table number 3, you have to name all of this table. Okay, carefully name that. Now this is what we do analysis or doing the Pascal principle. You can say just Pascal principle analysis, and then let's make another table, table 4. So on table 4, what we're going to do, you have to take a look the lab manual. Table 4, it asking you to do the pressure analysis with the Pascal, right? You can just type that here. Pressure analysis with Pascal principle. Okay, and then you need to make this table right here. I just gonna copy paste all the names from my previous table, right? So this is the names from the previous table. Okay, then you can do the rest here. Now you know pressure due to mass number one. Mass number one is doesn't change at all, right? Pressure due to mass number one, which is m1g. You can see the equation here. m1g time divided by a1. These are cylinders. a1 should be pi r squared, right? So you have to make that, right? Do the calculation. Equal sign. m1 is 1300, which is 1.3 times the gravity 9.81 divided by parentheses a1 is pi times r square 3.14 times r is actually 50 millimeters, which is 0.05. 50 millimeters is 5 centimeters to the power 2. Okay, to the power 2, close parentheses, enter hit button, you will get answer. Now these answers, let's do it in scientific format. You can do this in scientific format cell, scientific format up to 4 significant figures. So let's do 4 significant figures. Okay, so I have the number in right format now. Unit should be on top, all the information there now. And let me copy that equation to the next cell. You can refer that when you do the calculation later. So that's the function I'm using to do the calculation above, okay? And whenever you need to do a function, make sure equal sign is in front. Otherwise, it will not do any calculation. Pressure due to mass M2, the same thing, exactly same calculation. Only thing is actually you changing. You can copy paste here and then edit whatever you need. So the mass has to edit now. That mass values is actually on your previous table, right? So the easy way of doing this, you can see I can change this mass 1.3 into this cell. Whatever the cell value there, you click that cell. And then radius on tube number 2 is actually 20 millimeters. So that will do the calculation automatically. And pressure due to height is actually rho gh, equal sign. Rho is 1000, right? This is water, times G is 9.81 times height h is actually this last cell right here. Just click on that. That will do the calculation automatically for you. Okay, good. Question? That is pi, because A is pi r squared, right? A is pi r squared. This large A is pi r squared. A means pi times r to the power 2. Okay. Pressure from fluid of height, and then pressure on tube 2. Now pressure on tube 2 is actually addition of these two, right? So unit has to change here. Unit should be meter to the power square, Newton to the power meter square. So make sure you adjusted the unit correctly. And then pressure on tube 2, the same location is actually you have to now add. This part is no needed there. Pressure on tube 2, the same level of the water is actually addition of these two, right? You can add these two columns. Okay, let me copy paste all this function just below that. Then you can refer that as you needed. Please try to practice this if you really want to learn the Excel. Otherwise, if you're still using the calculator, then you have to think only one thing, where I am compared to the time, whether I'm in 10 years behind or I'm in the right time as the other people in, okay? So that's the thing you have to think yourself. And if you are in very advanced level, want to use the MATLAB or Octave for this data analysis, go ahead. Just do it then. That's fine with me, okay? And then do the percentage difference. Now the percentage difference here I need between pressure on tube 2 and then total pressure on tube 1. Okay, pressure on side 2. Let's say here different name here. Total pressure on side 2. Total pressure on side 2. The same level, otherwise you might confuse later. Side 2 on the same level. Okay, question. Area is pi r squared. Right here. That pi r squared is 3.14 times r radius to the power 2. And let's do percentage error equal sign ABS, because I need only absolute value, right? And then in this case, we are calculating percentage different, okay? Not the percentage error. That's something also you have to keep that in mind. So let's put another parenthesis there. ABS, I need pressure on side 2 minus pressure on side 1. Close parenthesis, divide by another parenthesis. I need the difference between these two. This one plus the other one. Close the parenthesis, divide by 2. Close the outside parenthesis times 100. So I'm getting very, very less amount of percentage different, but it's still there as a small percentage different. That must be the case, okay? Let me copy that function here for later references. Okay, then you continue that through rest of the calculation. Okay, as you go downward direction, this you can see mass 2 is changing, so you have to do this calculation also accordingly. Okay, so the easy way to do this calculation is actually this way. Let me copy this whole thing into here. You can refer that as it is needed, and then erase here. Let me show you how to do that very easily. Now, since you already done calculation on one row, rest of the calculation you can do it very easily. So if you click this and drag, so I need 4 more other calculation. So that calculation automatically does it for you. So that's the advantage by using the Excel. Okay, so we're not going to do any of the calculation. Instead, we do only one row and then click and drag, so that will done automatically the calculation for you. And also you have to reset all these significant figure values, right? That should be about 4 significant figures. Scientific, 3 decimal places will give you 4 significant figures. Scientific, format cell, 3 decimal places will give you 4 significant figures. Yeah. Okay. It doesn't matter what tube you talking about, but you have to follow carefully what the simulation show you, right? Simulation, right hand side is M1, M2, left hand side is M1, right? So this is M1, so that's not going to change at all. So the pressure on that side, keep it same. That is not changing at all. What's changing is your right hand side. So that we done calculation by using this one, okay? And then if you go into the right hand side, the same level on the simulator or the Pascal, you can see right hand side same level. Then you have total pressure need to be added up. This is the same level compared to this piston right here. Then the total pressure is actually addition of these two. So that's the calculation. Then what we're checking is total pressure on your left hand side, just M1 times the G. Total pressure on right hand side, M2 times the G plus rho times G times H. Then we're checking whether those two are same or not. If it is same, then we have the right answer. If not, If it is same, we know the Pascal principle is correct, and then if not, Pascal principle is incorrect. Good, any question? So this part right here showing you the function for this calculation, okay? This part right here are the function for the calculation. It's right here. All of these are the function. This is the function for M1 G over A1. All of these functions right here. And this is total pressure on side 2. Total pressure on side 2. And then this one is how to do the percentage difference between P1 and P2. Okay, good. Any questions so far? Everybody okay with that? Now, you can see the advantage, right? If you doing this, if you write it down, this information on a sheet of paper, doing the calculation with the calculator, that's fine with me. I don't care how you do it. You can do any way you like, but you're wasting a lot of your time. And then the skill point of view, you're not gaining any skill at all. What is needed for you in the future? Okay, you are in maybe 50 years back in time. You need to think about that very carefully. Okay, so what is needed today is actually how to use this computational thinking. So you have to think like the how the computer is actually processing. So that is actually very beneficial in the future. Whether we like it or not, everything gonna be computerized, right? So now the education is totally becomes virtual. Everything gonna become some sort of computer related activity in the future. Okay, guys, everybody okay with this part? Formatting, I will let you to try that later. Please play around. If you have any huge difficulty with anything, always reach out. I can either help you, talk to you, or I can send you some resources where you can actually learn that easily, okay? Good, any questions so far? Everybody okay with that? Good? No question? Okay, we completed all the tables, all the calculation except this calculation on table, this table. Okay, I done only for water, but the rest you can do easily because you know how to do that percentage error analysis. Okay, guys, so let's see the last part. So the last calculation, table 5. So table 5 we're going to do. We're going to check analysis of Bernoulli's principle, right? Let's take a look on your lab manual, how that table is actually set up. So the lab manual telling you do the Bernoulli principle, and then we have a tube on your simulator. We're gonna let the water flow through the simulator, and then gonna calculate certain thing by using the simulator, and then analysis will be done to check whether the Bernoulli principle is correct or not. That's the plan. Okay, if the Bernoulli's principle correct, what we're doing with the simulator must show you the right result. So let's take a look the simulator first. So this is the simulation for the Bernoulli's principle. Link is on page number 3 right here. Just click that link. That's a different type of simulation. Click on the begin here, then you will get that simulation page. You can see there's a tube and then water is flowing through that, and then there's a pressure gauge, right? So the inside pressure, outside pressure, you can read directly. So let's take a look what's the lab manual suggesting you to start with. So the lab manual suggesting you adjust the radius of the side 1 to the maximum value and then side 2 the minimum value, because then you will get a fairly decent pressure difference. So side 1, adjust the radius to the maximum possible value. Increase that into the all the way to maximum. I can change only to 19.4 centimeters. Green arrow, it represents the input side. Blue arrow represents the output side, changing to the minimum possible value, which is 5.3. Not the speed, actually, radius, okay? Green arrow. Change it into the 10.5. You can't change anything more than 9.7. That impossible. If you click this up arrow, that should show you about 19.4 centimeters, which I have. That's fine. If you have 19.7, that's okay. Those numbers will be slightly different, I think, because it's randomly generated maybe. So on your side, you will see a slightly different number. And it should be close to 19, good enough. And there should be a fairly decent different, otherwise we will not get the pressure different large, okay? That's okay. If you have like something 19 on input side, 10 centimeters on other side, that's okay. Just leave it like that, nothing to worry. And change the water speed, moving speed into the smallest possible velocity on your left hand side, input side. What you talking about? What M2? Which part you talking about? Pressure is M2G divided by A2. Radius of the tube is extremely small, okay? Radius of the tube right here is 0.02. You have a denominator 0.0 to the power 2, that is 10 to the negative 4. When that 10 to the negative 4 goes to the numerator, it becomes 10 to the positive 4. Okay, so that becomes a really large number. Because of that, only place where you can see, check these two columns. So that's the place you can really see whether we have the right numbers or not. These two numbers should be the same. Then the Pascal principle is correct. Okay, that's the idea. So we have fairly decently close numbers. So that's why your percentage error is extremely small. Okay, guys, so now the left pipe, make sure the pressure is automatically selected. We can't, you can leave it like that. So the radius, largest possible value, velocity, leave it to the smallest possible value. And the right-hand side, change the radius into the smallest possible value. That's all, don't change anything else. So we don't have any other option to change there at all. Leave it there. And then let the water flow. That will show you the pressure on the other side, right? So what we're going to do in this part of the lab, so we're going to do this calculation to analyze the Bernoulli's, right? So let's take a look how we're going to do this. Now part C. Bernoulli's, now you know if I have a large tube here, other side if the tube becomes smaller. So I have certain things here, A1, B1, and then P1. Other side A2, V2, and then P2. Remember A1 and A2 are pi r squared in each side. So now what the Bernoulli is telling you is that P1 plus rho GH1 plus half rho V1 square, which is equal P2 plus rho GH2 plus half rho V2 square, right? But since the tube is on the same level, we'll get rid of the potential energy term, right? Then I'm going to end up with only these two. Since I know all of these information, right? I know all the pressure values, I know all the velocity values. Now, how are we going to analyze this? We'll use the velocity values we selected here. Accordingly, we'll calculate P1 minus P2. We'll do that calculation. So we'll calculate P1 minus P2, which is half the rho V2 square minus V1 square. And then let's compare that to the directly observed P1 minus P2. we can actually observe this one directly. We can observe that directly because you see these pressure gauges, right? You see the pressure gauge. So I can directly observe that from there, pressure gauge left hand side show you the P1, pressure gauge right hand side show you the P2, right? So let's extract those two numbers directly. It says in kilopascal, remember, okay? It says kilopascal, which means number must be multiplied by 10 to the power 3. So after we get that, we can actually compare these two. That's all. If I am getting the same answers from calculation and then the observation, then the Bernoulli's principle is correct. Otherwise, it may not be accurate, right? Only error can happen here is the density value which use, the density of the fluid which use in the simulator must be density of water. If not, then we might not get the right answer if we're using a different number. Okay, let's take a look at that. All right, so let's make a table very quickly. So this is very simple calculation again. So speed of the tube 1, I need the radius of the tube 1, speed of the tube 2, radius of the tube 2, measured pressure, calculated pressure, percentage difference. Okay. So let's build that here. Table 5. Table 5, which you can just name it as what we analyzing the Bernoulli's principle, right? Analysis of Bernoulli's principle. Bernoulli's principle. Okay, so the table column 1 is speed of the side 1, so that is actually V1. So unit is meter per second. Column 2, radius of the tube 1, so that is actually R1. The unit should be in meters. V2, unit should be meter per second. And then R2 unit should be meters, and then I need measured pressure difference, so that is actually delta P. You can also say P1 minus P2, P1 minus P2, but measured value, right? So let's say P1 minus P2, which is measured directly. Measured directly or observed directly, you can say OBS, observed, or measured MES to represent the measured, okay? Measured value, and then I can do the same here, same pressure but calculated. P1 minus P2, let's do calculated. Okay, these are in Pascal, unit Pascal. So all of those information should be there when you do this as a calculation, right, on your lab report. Okay, side 1 is speed right now 5.3. Only I can read two significant figures. R1 19.4 centimeters, but I need in meters, so you have to divide that by 100, 0.194, 0.194, and then V2 18.1, then R2, which is 10.5, which means 0.105. Then pressure different you have to read on here. Pressure different P1, which is about 305 kilopascal. And then the other one, which is about 155 kilopascal, right? So the 305 minus 105, 305 parentheses, I'm going to do that calculation here, equal parentheses 305 minus 105 times 10 to the power 3, because that's in kilopascal, okay? It's better to maybe change everything in SI, in scientific notation. That will looks nice then. Scientific notation, and let's use 4 significant figures everywhere. Go consistency, keep the consistency. Okay, now let's calculate this one. This one, you know, equal sign. 0.5 half is 0.5 multiplied by 1000 water density multiplied by parentheses V1 is squared, right? This is V1, so you can take a square of that, minus V2 is squared, this number, parentheses, square of that, close the parentheses. So I'm getting little bit of error, but that's okay. So absolute value sign, okay? So put the ABS because we don't care the sign, we need only positive value. Okay, this is 2 times 10 to the 5. This is 1.5 times 10 to the 5. That's okay because the density value which you use on this calculator, we don't know exact numbers. That might be an issue. You can use the density of the fresh water. Okay, good. Any correction so far? Anyone have any problem with that calculation? Now let me calculate how, let me put this function too, then refer that later. So this function is actually P1 minus P2, but observed value, okay? This function right here. And then this is the function which I'm using to get the calculation for P1 minus P2 by using the velocities. Because you see this equation, right? Now let's take a look at that equation quickly. All right, in equation you have this half, right? So I just put it as a 0.5. You can do any way you like. You can just put half there, doesn't matter. It still should give you the right answer. Okay, so then after that you have to calculate this. Let's do the percentage error too, right? So the question asking percentage error. Let's do percentage error here. Percentage error also we can do percentage different only, right? Because we're comparing two calculated values. Percentage difference equal sign ABS parentheses this number minus the other number divide by parentheses addition of both numbers plus the other number and then divide by 2 to get the average, multiply by 100 to get the percentage error. I'm getting about like 6.6 percentage error, close enough, because pressure values we're reading directly. There is some inaccuracy there, but it's close enough. Now, everybody okay with that? Anybody have any problem with that calculation? Should not be difficult at all. All you have to do is just carefully extract the data and then do the calculation yourself. It should not be difficult at all. Everyone okay with that? So now you can see this table number 5 has actually a few more other rows, right? Which means technically it's asking you to do either changing radius or changing the speed on that side, right? So let's do, you can change at one parameter at a time because changing every parameter doesn't make any sense. So let's change velocity input side little bit, or maybe radius input side little bit, and then calculate the other values. So which one is the best to change? Let's take a look. So the repeat the above step by increasing the speed of the tube number one side. So they keep everything else constant, don't change anything. We'll change the speed of the side one and then see what will happen to the pressure different and the speed on the other side. Let's do the same calculation. Let's increase this one, for example, the speed. Just click only once, this blue up arrow. Now you can see it changes automatically into 7.4. Only this number I'm changing now, okay? This number is now 7.4. Everything else keep as it is. Don't change these at all. R1 and then R2 keeping the same. V2 will change. V2 now 25.3. Now you can see that changes 25.3. These two are same 1.94 and this is 1.05, not change at all. These you can calculate. Now you see, you remember, if I done one calculation of the row, you don't need to redo again, just copy paste here. It will do the calculation automatically for you. You see that? It will does the calculation automatically, okay? So likewise, you can do a couple of other values. Here, let's increase this number again, little bit. Let's see how much I can change this velocity. So the velocity maximum you can go that all really. See, it doesn't allow me to change the velocity. All I can do, maybe I can keep the higher velocity and then change the radius and then see I can get a different number. So let's do that. We'll change the radius on next step and then read the numbers again. So next step we'll do keep the velocity 7.4. Instead, now I'm doing 18.4 in input radius. And then output radius keep the same number. And input side and then output velocity is 22.7. Now the pressure values you have to read, okay? One thing I forgot earlier, this pressure value is actually changing for each case, okay? This part you have to do carefully, okay? You can copy paste this calculation, that's fine. But when you copy paste that calculation, only thing you have to keep that mind is the pressure measured, P1 and P2 may not be the same as previously now any longer, right? You have to keep that mind and then change the pressure accordingly. Okay, let's go and take a look. Input pressure, you can see it's about the same, 305. We are not changing that. But outside pressure, you can see it is changing by large. So you have to do that accordingly. So this one now 50, 60, 70 kilopascal, which means you need to edit this calculation into 70 kilopascal. That's all really. This is now 70. Okay, accordingly you will get some error there. So very, very less error now. This one also, previous calculation also, I think I have to check that error again. Keep this there and then let it run. Pressure inside keeping constant, pressure outside is changing as the system, as the water flows through that pressure sensor, okay? Wait until it zoom in, okay. Now you can see pressure there is actually only 10 kilopascal, so I have to edit this. This is only 10 kilopascal. Okay, so accordingly you will get the error. So we done 3 different values. You can try at least 1 more or maybe 2 more numbers. What you can do is that seems to be velocity, it doesn't let you to increase more than 7.4. You can start decreasing the radius, right? We done 18. Next one, keep the same 7.4 and do the velocity input side. Same velocity, the radius input side 17.5. And make sure you format everything on table number 1 to represent 4 significant figures, okay? Which means format cell, scientific notation, 3 decimal places will give you 4 significant figures, okay? Now I'm changing radius, okay? Because the velocity doesn't let me to increase anything more. Now the velocity other side, 20.6. Radius keeping the same, 1.05. And then this calculation you can copy and paste. Make sure when you copy and paste, pressure observed must be different because pressure on side 2 is a different number. You have to adjust only that. Now the pressure on side 2 is 120. So you have to change that accordingly, okay? Good, any questions so far? Now this number is 120. Okay, any question? Everything is here on this table now. You can see what I changes, right? So you see what I changes. Initially, V1 is 5.3, and then I change that into 7.4. Then I keep that velocity, and then I'm changing the radius input side, okay? Accordingly, what you're observing is V2. These numbers you have to extract, okay? These highlighted values you extracting from the simulator, and then these values you have to observe from the simulator accordingly, right? Particularly what you're observing is P2. P2 you have to observe from the simulator, okay? You can do this later. You know how to do the simulator, so you have to observe this one. Take from the simulator, okay? Take from simulator. P2 must be take from simulator for each case, okay? For each case. And then all these calculation will be done automatically. You just need to copy paste these 2 lines into rest of the calculation. You need at least 4 or 5 lines done for this last table, okay? Good, any question so far? Everybody okay? And this table, this data sheet you must upload, okay? So that's the one I was telling earlier. This table must be uploaded in here. This place right here, you can see the data sheet, lab number 1. That must be uploaded within 30 minutes of the class ending time today, okay? Please do that. That is important to keep track who's actually doing the lab with me or who's not. So that's important. Just logging in the WebEx is not enough, okay? You have to show that you're really working the lab. All right, guys. So any other question? No, you don't need to worry about finishing that. Whatever you have, you can upload, okay? Whatever the data you have, just upload. You can just direct copy paste the data there, or you can upload the whole Excel sheet, something you have to upload into the data sheet, okay? Why the table number 1? At least you have to have all the tables, at least some part done, right? Because we done all the tables. Okay, good. Let's take a break and then start in 15 minutes then. Not after 12:30. Are you asking this data sheet? No, this data sheet I will not share at all because you have to take the data yourself. Everything is actually we discuss. You should have write down somewhere, or the video has this information, okay? So the video will be posted, but I will not share the whole Excel sheet with you as Excel sheet. That's not much useful. Whole idea is that if you do yourself, you will learn. If you just copy paste something, you will not learn at all. Correct, yeah. So you see this, it says lab report is due midnight Friday, July 10. Data sheet must be submitted 12:30 or before July 2, okay, today. Okay, so let's take a break. Let's start 10:15 and then continue the chapter what we're working on yesterday, okay? Yeah, for the report you have like whole week, yeah. First 2-3 weeks you're going to have the whole week, but as we close in